welcome to the Racers HQ podcast. I'm your host, Matt Murphy, and joining me on the line tonight is our faithful co-host, Pat Mullery. Pat, how are you doing tonight, sir?
I'm doing well, Matt. Thank you.
Oh, thank
I prefer Intrepid, but Faithful's also good.
Intrepid. Oh, that's fine. We'll get you next time, boss. And a very special guest. I'm very excited about this. Brent Picasso from Autosport Labs. How are you doing tonight, sir?
Good, thank you. Glad to be here.
Awesome. Well, we're excited to talk to Brent about Autosport Labs and all the cool thing they're doing. But in the meantime, do a little garage updates, maybe a drink check. So, Pat, what are you sipping on tonight, sir?
Tonight, I am enjoying some Still Austin straight bourbon whiskey. Their sort of most mainstream flagship product. I'm on the road tonight, so I went with just what I could find and at the liquor store on the way here from the airport. So
smart. You got to get those provisions.
Yeah, I mean you can't pod 100% sober. I mean we have, but those are our worst pods. So
yeah. Brent, how about yourself? What are you using for refreshment tonight?
Oh my God, I have a lemon ginger tea. Although I should have turned it into a hot toddy. After.
Still time.
There's still time. We can do this garage update. You can make a quick
run.
Right. And I've got some Irish whiskey here. It was St. Paddy's Day recently, so picked up some Tullamore 12 single barrel.
Very nice.
So I'm enjoying it. It's nice and integrated, right? I don't like that weird, terrible flavor of like a real cheap JMO.
Right.
Anyway, so moving on.
No, we're not moving on. When Rachel and I were in Dublin in summer 2023, we went to the Jameson tour, and I like Jameson, the regular Jameson.
Yeah.
But they have it's not my favorite, but it's drinkable. They've come out with like 1,000 different other flavor profiles, orange and all sorts of stuff. And I haven't had one of those that I thought was worth the time.
Yeah, I can't imagine that good things are happening to whiskey when they add orange flavoring.
Right.
Yeah, this isn't, the quality direction.
But that's a fair assessment. Along the lines of St. Patrick's Day, do we want to talk corned beef?
We could do a quick.
Save that for some other time.
We could do a quick corned beef catch up. Call it kitchen time with Matt and Pat. That's right. I made a corned beef, cabbage, potatoes, carrots, the works. I do this every year. Pat, what'd you do?
I also did at my co-host's recommendation. I used the recipe from SeriousEats.com for brining and sous videing an entire corned beef or entire brisket, and then cooked it in the sous vide, and then cut it in half and froze half of it immediately because there was no way that Rachel and I, between us, were going to eat like 10 pounds of corned beef. Well, not eat 10 pounds of corned beef and survive another year, right?
Yeah, but, it's a deadly amount of corned beef if you do the whole brisket.
Yeah, but that recipe is it's a killer recipe. Like that is by far the best corned beef I've ever had. With that brine gets the flavor just right, and then I think it was in the sous vide for 10 hours, maybe like all day on the day before St. Patrick's Day. It's the way he recommends doing it, and then just take it out, throw it in the fridge overnight, and then cut it. And it's a lot easier to cut when it's cold the next day, and just rewarm it. I'm telling you, that recipe, good call, Matt Murphy.
It slaps.
Good stuff. Absolutely.
Yeah, it calls all the Irish folk to the yard. Like every St. Paddy's Day, they're over at my house.
The milkshake.
Yeah, it's like a milkshake for Irish people. Brent, do you have any comments on this topic?
Oh my God, I love corned beef. Actually, we had a late St. Patrick's Day celebration. Our friend invited us over on Saturday, and we got our fill with corned beef, Guinness bread, all the things. So, yeah, I actually got some Suntory whiskey also to add to my tea.
Nice. There we go.
Nice. There we go. We're catching up. Pat, didn't you made Guinness cake or something, right?
Yeah, Rachel did. It was a Nigella Lawson recipe for a Guinness chocolate cake. So it uses like 10 ounces of Guinness stout and then chocolate powder and flour and whatever else. And it was remarkably simple as far as cakes go. And, it wasn't like multi-layers with, like jam and stuff between them or anything. It's just a cake. And then it's kind of a simple, like sour cream and cream cheese frosting, which you whip the crap out of. So it was actually pretty airy. And I think the idea is that it looks like the top of a Guinness.
Oh, like a beer. Yeah.
Yeah.
Okay, that makes sense. Nice.
Kind of foamy on top, but that flavor of frosting worked great with the cake. It was a very moist cake. It was delicious. It was
great.
A big 2 thumbs up on that internet recipe as well. You strike out a lot of times on internet recipes. In this case, they were both 5 stars.
Good. Pat, have you done any garage stuff lately other than hang out in the kitchen?
Yeah, no, there's been a lot of garage stuff. It's been still working on the electrical rewire under the hood. I got that pretty much done last weekend, and so now it's just a matter of getting everything, the intake manifold back on and smoke test that, because of course that's a mandatory on an E36 engine. Make sure that you don't have the damned vacuum leaks, and then my hope is to get it fired up on Saturday or Sunday, depending on how this next weekend goes.
Sweet.
Yeah, and if I do that, then we're pretty close ready for Hallett.
Nice.
Yeah.
You gonna get a test day in, yay or nay? You think?
I hope so. Just depends on work, really.
Yeah. Quick garage update on my end. I am rapidly converting my car to ST4 for the event in Houston on the 13th of April. Installed a 1-inch master cylinder by 949 Racing in Willwood, and taking it to the dyno Thursday. XP Performance, I think, something like that.
Is that a bigger master cylinder to get a little bit more touch out of it?
Yeah, so I'm converting to my big brake kit.
Mm-hmm.
And so I had the big brake kit without the big master cylinder, and it was too spongy. I mean, it was weird.
Yeah.
So I didn't like it. But quick pro tip, don't ever do this. Don't leave your big brake kit backup like spare rotors and brake pads without any bags in them or around them, just sitting around in your garage, maybe where there's a leak, and maybe they all get rusty, and then you just throw them all away and buy like a whole new set and put you back 4 days. So anyway, that happened to me. I went to go find my spare big brake kit parts, and they were all rustied up.
I'm sorry, Matt.
That's fine. I wanted to switch to the Hawk pads anyway, so it gave me an excuse. And
you can just throw some navel jelly on the rotors and see if they were salvageable.
I was fresh out of navel jelly, but no, they were bad though. They were like pitted bad. Like
not like navel, like your belly button, like navel, like ships that float on the sea.
I see. This is like seal oil.
No, this is nothing like your seal oil imbroglio. This is a real thing. It's used to remove rust from metal surfaces.
Okay.
Like you put it on there, and it I don't know if it converts it or what, but if it obviously if it was pitted, it wouldn't do anything about that.
No, it was too far gone. I appreciate the heads up though, guys. Remember that if it's a light amount of rust, Pat Mulry's
navel jelly.
Navel jelly. I like it. Okay, well, let's move on. Let's do a real podcast now that we've talked about ourselves and our kitchens and everything. Brent, welcome to the show. It's so cool to have you on. We want to hear all about you. We like to usually start and to hear about people's racing history, how they got started on all this and what they're up to these days. And but then I know you've got a lot of other interesting things to talk about with your company, Autosport Labs, and your various products. And we're excited to hear from you. So why don't you tell us a little bit about how you got going, what you're up to racing-wise?
Oh, wow. That goes pretty far back. So I would say our racing started with doing SCCA autocross. So up here in the Northwest region. So we a friend of ours was like, hey, you could do this thing where you can race your car and it's safe. You could just get a helmet, and as long as your brakes work, you can drive your car with high performance. And we were like, whoa, no way. This you could totally do that. And then we were hooked immediately and did many seasons of autocross, first in our Acura Integra GSR, which was amazing car. Always is like our favorite car in a way. And then we went and I got the bright idea of my friend Scott and I had this inspiration to take our first gen Toyota MR2 and do a turbo conversion on that. Why would you do that on a mid-engine car? You know, that's just asking for lots of pain and suffering. You know, like the only way to drop the engine out of that car is to raise the back up super high. But yeah, I did this. It was turbocharging the 1.6 was like a work of art. But the
you built a Mark 1.5.
Yeah, that's true. That would be a better option. But so I was just kind of going back, like how we designed that engine, and back it goes that far back where we were using a Megasquirt engine controller, and it didn't have ignition control. So I was chatting in the Yahoo groups. I'm really aging myself here, but and chatting with the people who made the Megasquirt, and they said, why don't you could design a ignition system around a Ford ignition module. So we came up with this thing that we eventually called Megajolt, which is a programmable standalone crank-fired ignition system. We adapted that along with the Megasquirt version 1 to run that turbocharged MR2 engine, the 4AG ZE, which was a block that we used. And then that was kind of like the genesis of Autosport Labs, because what I ended up doing was I made a few hand-etched circuit boards with these program processors, and then I said, like, hey, would anybody want one of these? And people were like, you know, a few hands go up, and then I like mail them to various people around the world, and then it kind of snowballed into like people wanting kits, and then people didn't want to build the kits, so we were building them ourselves, and then we ended up getting you know, like electronic assembly equipment. It was in our garage, you know, like pick and place machines and solder machines, and then eventually we were selling a lot of those to different parts of the world. It was really popular with people with like minis, like and MGs in the UK, because they had crappy ignition systems. So it really would really modernize those vehicles. So we thought, well, this is cool. Like, what else could we make that could be like car or motorsport related? And then we thought data acquisition could be like a deep and wide domain that we could like step into. So I came up with a design.
You feel like you fell into the deep end with that?
It was kind of like you don't. It is one of those things where if you knew how deep and wide it was, you probably wouldn't do it, right? So there's some like naivete there.
Like like most motorsports, right? This can't be that hard.
You don't want to be cursed with too much knowledge. You want to be a little like naive, right? Otherwise, you might talk yourself out of doing something.
Yeah, the Dunning-Kruger part early on is critical.
It's super. Yeah, you just have to have like the will to you're just gonna work through it and try to figure it out. Otherwise, yeah. But like so we made a kind of a version 1 of our data logger, the first version of Race Capture Pro, and then I don't know where I got the idea, but I think it was the I got the idea with a cellular module where I connected that cellular module to the race capture system, and it was like in a Tupperware lid, and instead of doing like live telemetry, I was sending SMS messages to what was called Twitter back then, and the car was tweeting as it was racing. So we made like the first self-tweeting race car, and then as it was clicking off laps, and then like getting, as each driver would like have the fastest lap time, it would actually tweet and say like, oh, Scott got the best lap time, or or Brent got the best lap time, or the last lap time was 2 minutes 5, or whatever. And then we did that, and I think it was I don't think it was it might have been the inaugural Chump Car race in Portland, the very first Chump Car race that they ever had. That was a 24-hour race. It might have been that or another race. But after building that, all the tweets are still up on Twitter, I think, unless they've deleted them. But
can I ask real quick? Are you still in the Acura at this point, or have you moved on?
No. I'm sorry. This is not the MR2. This was in a Miata, like a first gen Miata. Okay. That was our endurance race car for Chump Car, which at that time. Yeah, good question. But so after that race, we're like, okay, this is kind of cool. We made like a tweeting race car, and then it dawned on me like, oh crap, we could do real-time telemetry that brings like what F1 teams and NASCAR teams get for hundreds of thousands of dollars, but like bring that to the masses. And then everything else is kind of history. So we kind of just started building that with different versions of our hardware, and just kind of moving forward to like today. So
it's wild.
I know I glossed over a lot of the uninteresting part, but the origin story I think is kind of the funner part.
Brent, that's especially interesting for us because our team started with AW11 also.
Oh, cool.
We had a first gen baby blue originally, first gen slick top, and it transmogrified over the years. Eventually became a Civica bodied MR2, and then we've been running the BMW for the last almost 10 years. Probably 10 years this year.
Was that in Lemons that you ran it in? Oh wow! So our Lemons race car, it was a Merkur XR4 Ti.
Oh my gosh!
Yeah, and then we ran the original Pinto turbocharged Pinto motor, which would love to blow head gaskets. I think we had a race at Thunderhill. It was like, how like the moments where you experience the most pain are the ones that they end up being like the best memories, right? But
we discussed that phenomenon on this podcast an awful lot.
It was so it was like a Friday test day, and you know how many cars blow up on test days, right? On the Friday. So we had some detonation in cylinder number 3 on the Merkur. Surprise, surprise, right? And then we're sitting at the Denny's next to Thunderhill. We're like, crap, what are we gonna do? Oh man, are we just gonna like, on one hand we could just run it until it blows up, and then we're like talking about different options, and I'm like, let's just disconnect the injector for that cylinder and let it be like an air spring. Cylinder number 3 is just an air spring. And then we ended up doing that. And then the whole race, it was basically a 3-cylinder turbocharged race car. But we're still beating our sister team with the Peugeot. We're still pulling on them, which was something we laugh about to this day. But it sounded like a Harley on track, and the car vibrated like crazy. And then we did the whole race and finished in the top third of the race.
Amazing. Nice. That's awesome. Right.
Yeah, that was like a really, we had some really good laughs and really good memories from that one.
All right, Brent, were
you running the Megasport on that?
That was running. Yeah, we were running a Megasquirt and our Megajolt system at the time on that car. So, who knows? Maybe that contributed to the detonation. Bad tuning, or maybe it's just because it had a cast iron head and it wasn't designed for endurance racing.
Right. Yeah. or something completely different.
Yeah.
Exactly.
Brent, you've mentioned a few tracks. What part of the country in general are you? Like California or?
So we're in the Seattle area, so Pacific Northwest. So when we race, we so the tracks that I've raced so far is at the Ridge. Not officially Pacific Raceways. I've done lapping days there. Portland International Raceway, Oregon Raceway Park, Thunderhill, Sonoma. That's the range that I've had the privilege to do so far.
Nice.
So yeah, definitely West
Nice
Coast.
tracks.
Oh, and also Laguna Seca.
Yep.
So I was lucky to do that.
Very nice. Yep. It's a nice. I love the California tracks. Very good. Okay, so you're doing all this endurance racing. Yeah, I guess you've done. Is it primarily Lemons or Champ Car, or what's kind of the mix there over time? Or
so over time, yeah, we did do quite a few Lemons races with the Mercure and also the Peugeot from our sister team. And then we started participating in Lucky Dog here in the Pacific Northwest, and also with Sonoma, different racetracks. And that with that team, one of our team members has a second gen MR2. So I'm like running down through the specs. It's gone through a number of iterations, but what they were working on with the car was trying to figure out how to get a reliable transmission with the V6 truck motor that they were running. And so on our team, Gil we were trying to figure out how to get the transmission to not blow up or like wear out the synchros prematurely. So he was trying to do an auto shifter, and then went to straight gears with pneumatic shifting, with paddle shifting. This is getting into some pretty expensive solutions, but what ended up happening, what he ended up doing, which was brilliant, was the V6 motor with a GTI dual clutch transmission.
Wow.
And then the two were mated together. The ECU and the transmission controller had required some extensive tuning to figure out how to like shift properly. But that combination was like a dream because you could do like with the dual clutch transmission, you could shift mid corner without losing any unsettling of the car. It was just like a high end race car. And the car's like way faster than I am, but it was amazing to drive when we last year when we drove it at the Ridge. So yeah, that's the Autosport Labs unofficial race car, where it's kind of like half of the weight of the vehicle is with our equipment on it.
Nice.
But yeah, it's got all the sensors, all the tire temperature, the dashboard, race capture, telemetry. So it's great. Like we after that experience at the Ridge, I was like, we need to take this to Sonoma. So last year it went to Sonoma. It was running great, but we had an off and the frame got torqued, so the car's being rebuilt. But yeah, I love Sonoma as well. It's an amazing track.
Yeah, it's a fun place.
Yeah.
That sounds rad. No, I think it'd be neat to see a car that's completely kitted out with all the top of the line Autosport Labs gear.
We're building. Yeah, we're actually. Have you heard of the Exomotive Exoset kit car?
Yep.
So our trump car racer was first gen Miata, and then it got crashed many times in the front end, and like it was pretty messed up, and it was sitting at our.
Don't they call that Miata disease?
Yeah.
Well, both front corners were, because we had an off during the 24-hour race, and it went into the tire wall, and then it was in pretty bad shape, and we were about ready to recycle it, and we were just like, we were at the lab, like doing some work, and then I think our friend Scott and Kelly were on the computer, and then I'm like ready to call, the pull apart place to come just haul it away, because we're just like, we're done, right? And then Scott brings up the Exoset website, and it was like and the Exomotive Exoset is a way to turn your Miata into like something that looks kind of like an aerial atom with an Exoset frame. So you throw away the body, and you got the skateboard, and it's mated to the Exomotive chassis, which is like an exoskeleton tube frame thing, and then that makes you have your ultra lightweight car, as if the Miata was heavy, but like all in, it's a like a 1,600-pound vehicle. So we got the race chassis, the race version that has the full cage, and then that was our project car. So that's like when you're saying like all the car that's all kitted out with our tech, that was going to be the thing that we bring to an event or a race or whatever that has like all of our sensors. And it was cool because it was all exoskeleton open. You can kind of see everything. It's kind of like the inside out person.
Right.
Like the kit where you could see a human body, and all the organs. But that was the idea. But we were on the way to getting that built, and then I thought it would be a lot cooler if we converted that to EV. So the current project, it's our friend's race car fabrication shop, Chase Race in Duvall, Washington. He is adapting a Tesla front drive unit from a Model S to the rear of the Miata with some custom axles, and made by Profab, I think. Yeah. Anyways, that Tesla drive unit is going into the back of the Exoset, where the rear subframe is, and then that's going to be when we get that working, that'll be our our fun car.
Nice.
So
batteries in the front.
Yeah, I think we're going to put a battery pack kind of like in the front, kind of like front where the tunnel goes. And I have to figure out the BMS system and all the other electronics. At the time, I kind of rationalized it as like, well, it couldn't be any harder than just like getting an engine plumbed in and everything. And then, of course, it's kind of like one of those, Dunning, like we're talking about the Dunning-Kruger effect. Like, how hard could it be? So I guess we'll find out. But I think that'll be the good thing that I did was I gave it to somebody to actually do the fabrication, so it actually gets done, versus being a project that's always on the back burner. So that's the good part. And then I can handle the electronics and the wiring and other things. I mean, I better be able to handle that, or else there's a serious problem. But yeah,
well, it's awesome. I love that. I love that you're building that kind of hero car with all the kit. So what's the current state of Autosport Labs? And maybe we can use this to transition into some of the cool new things you guys are doing. I understand there's new product, new software, and I'd like to dig into that.
We need a breaking news sounder here.
Beep, 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 beep.
Here we go.
Yeah. So we have released many generations of different products of like different versions of Race Capture products. We have a Race Capture Pro, which is kind of like our Swiss Army knife that has all the sensor inputs, CAN bus, and everything that can like live stream to the platform we call Podium. That Podium is kind of like Strava, but for race cars, right? And then like Race Capture would be like your Garmin watch or a Fitbit. So like if I'm at a party, they're like, what do you do? It's like, well, we do like, it's like like a Garmin plus Strava, but for race cars. So the Race Capture system, that's in a couple of different variants, and then we have this thing called Podium Connect, which is a little telemetry bridge that takes an existing AIM, Motec, ECU Master existing data system and adds live telemetry to that system. So the backstory was we were exhibiting at our one and only time exhibiting at PRI. We were showing off our first gen Race Capture system with the telemetry add-on, and then people were like, that's cool, but if I already have a data system and I buy this, it's kind of weird because I would have two different data systems. So Kelly, our co-founder, had the brilliant idea of like, well, why don't we make a thing that adds telemetry to their existing data system so it feels like they're enhancing their existing investment.
Mm-hmm.
So that's where Podium Connect came out, and that's a box that has a cell modem. You put a SIM card in it, and it has CAN bus, so the CAN bus connects to their AIM or whatever system, and then it live streams to our platform Podium. And then the live streaming telemetry is good for, all the endurance racing things, like making sure your car's not blowing up on track, and you could do real-time driver coaching, all the things that matter when you have real-time access to your data versus after the fact, and that really matters for endurance racing. So after a few generations of all of our products, and then a couple of generations of our Podium Connect system, we're coming out with a version of Podium Connect called Podium Connect Micro, which is a very small, lightweight version of the Podium Connect system that will connect to an in-car hotspot. And a lot of people are live streaming video nowadays from their car because endurance racing and, showing off with friends. So we're kind of like piggybacking on that. And
because they've already got the hotspot to push.
They already have a hotspot.
Video data. Yeah.
Exactly. Yep. So it's a way to kind of create like the powerful and lightweight version of that system, and then that can bridge the CAN bus data coming from whatever system that they have up to Podium, and that's the product we're launching now. So the marketing 101 is like you want to have a small, medium, and large offering. So that'll kind of fill the slot of the small offering, but not necessarily cheap. We kind of want to make that distinction. But it does have some really cool features, and we're also launching some capabilities for endurance racing that is really specific to endurance racing, unique to which doesn't really exist with like sprint racing or time attack.
Sure. Yeah, so you built this new product. I understand it's a bit more of a hardened product. Is that correct as well?
Yeah. So it's has an IP6. It's our first product with IP65 rating. So it's completely sealed.
Pretend like I don't know what an IP65 rating is, Brent.
Yeah. So that's all the lingo. So there's different ratings. So IP50 is like you can have dust. You could have dust and water ingress, and you basically you don't want to put it in a harsh environment. IP65 means that it can go kind of in a moist and dusty environment without affecting it in a detrimental way. And you need that in a race car because we'll send out a product in its box, and it's all shiny and new and nice. And then if we get one in that's been that needs repairs for some reason, it comes back all dinged, dusty, dirty, maybe even like it's been flooded. Right? Like if there's rain comes in, you can kind of see evidence of like a little bit of dirt like on the circuit board. It's like, wow, this thing's been like underwater for a bit, but it still works. That's weird. So it took us a few years, but we're like, stuff that goes into race cars needs to be pretty ruggedized. So it is our first product that is that's sealed. So we put a ton of effort into the mechanical part in it, and our friend Peter from Australia did an amazing job on the enclosure design and then the way it's sealed and everything. So worked on the overall thing for over a year.
I've got a question about that. Is that IP 56? Is that what you said? 65?
IP 65.
65. Is that something you can self-certify, or do you have to send that off to some organization and then they run it through a battery of tests and say, it passes?
There, that is something you can self-certify, I would say, and then we did do that. The reason why is that because the spec is online on what makes that certification. Yeah, there is like a standard for doing that. Yeah.
Nice.
But I mean, yeah, there are other certified like standards bodies like UL Labs. You can like if it's like UL rated, then you could put the little emblem on there.
Right.
Yeah.
So very cool. So I like your idea that you're it makes sense, right? So like why mess with another cellular modem? I'll tell you that's one of the more annoying things to mess with, especially if it's, you know, like what's cool about all the modern cellular modems is like you can just go to Verizon or T-Mobile and just get one, right? And like you're not having to mess with compatibility on an old board or anything like that. So I really like the idea of decoupling those situations because it's always an. I mean, I really like your product, but it is often annoying to try to like, oh gosh, I forgot to renew my plan or something like that, right? And yeah, it's just one more thing to have to mess with, right? But I like the idea.
Yeah, and then like
Mhm.
yeah, like Starlink is a thing now in race cars.
Right.
So
Is it really?
we see, yeah, like with the Starlink Mini, they people are running in that in endurance racing, and they're also running it in off-road racing too, especially with the long distance racing. So that's an area that has gotten attention on our products because they need to be able to see what's going on with their long distance off-road racing, and they want to see how the car is doing, where the car is, the speed, the engine sensors, and even sensors attached to the driver like heart rate and stuff like that. So the Starlink Mini is super compact. It's funny, they said do not use it over 100 miles an hour, but I think their main concern is if you're traveling across the face of the earth at high rate, then it's constantly switching satellites. But if you're in a local area, like in a racetrack, and just going in a circle, it shouldn't matter how fast you're going in that case. That's my theory, at least.
Nice.
So
That's pretty cool.
so it'll work well with
Open,
a Starlink Mini because of the hotspot.
so it just opens up a whole new market
Oh yeah,
for
that's
you. You
really
can do
cool.
off-road stuff. Yeah.
Yeah, Ultra 4, King of Hammers, all those. It's a whole another world of motorsports. So yeah, I've been kind of like joking with when I talk to people about what we do. It's kind of like, well, our product works with anything that has like a motor and is raceable, but like endurance racing with a car on a road course, that's a few levels deep in the genre of motorsports.
Right.
But it is something that we really want to do a good job nailing for that genre, that sub genre.
Well, can we talk about that a little bit? So you do have some new tools that you're coming out with from a software side, and I think it's pretty fascinating. I understand there's things like driver tracking and fuel strategy. So I don't want to give it all away, but could you just talk to us a little bit about those features? Because we love. I mean, we love to. I remember one time at just real quick at Sebring, we had 4 monitors up, and for a brief moment of glory, we looked like a real slick team until our wheel fell off in like turn 12. But
you didn't have like
Go ahead.
You didn't have the lug nut sensor? I mean,
no, we did not have a lug nut sensor.
We didn't have load sensors on our lug nuts, as it turns out.
Yeah.
But I'll tell you, one other time, it was a race Matt wasn't at, but we took the car to Colorado for a race, and we were running the full telemetry there. And where it proved really useful at that race was, of course, so the car lives with me at 760 feet above sea level. We're racing outside of Denver at basically 5,000 feet or whatever that is, right? And we start watching the water temps creep up, and car's running great. It was running lean because it had been tuned for not altitude, and so by being able to watch that on the laptop in our tent, we were able to say, hey, we need to just back off the gas a little bit, not run this thing all the way out, so we get a little bit more cooling through it. We just can't create as many BTUs because it can't shed them between the tuning and then just not having as much air to cool it off. And it saved the engine. It saved we didn't overheat it. I mean, I don't know how well BMWs. You overheat those things once and that engine's pretty much done. So the head at least is going to come off and be, decked, and you'll be lucky if you don't, throw a rod.
Oh yeah, I know BMW's. My E36 M3, the fan clutch was wearing out, and stop and go traffic overheated, and the heater core exploded on my feet.
Oh my god!
So
gross.
Yeah, that was fun. But that was my daily driver. So I love that car. But yeah, I think my favorite thing is the like, especially if you get this insight and you can avoid it, is like the oil pressure versus G-force. Because if you start dropping oil pressure, it's kind of like it's like a hidden danger, right? You don't know that it's a problem unless you can actually see it in real time. But like, let's say you have a high G corner and your oil pickup gets uncovered briefly. So that's like you're slowly wearing out your rod bearings, and then you have rod knock sometime later, and you're like, I don't know what happened. It's just like the engine, right? But then if you had that information, like, oh crap, we're like oil starving in those corners, you could do something about it, right? Like put in a baffled pan, or make sure you're topped off with oil all the time.
Yeah.
If you're slowly burning off oil, you could, like it could be not a problem at the beginning of race, and then mid stint or mid race, you start having the problem. So that's a huge one that your pit crew can pay attention to, that the driver has no way of knowing. Like, driver can see an idiot light, like, oh, we're like overheating, but they don't have the cognitive capacity to pay attention to like second order things like oil pressure in a corner. So that's a really good big one.
Yeah, Dave, I'm going to tell you, Dave's one of our listeners. I can count on him taking notes while we're going along. If I throw this out there, Dave, could you make a note and send it to me to add G-force versus oil pressure into our dashboard for future races?
There you go.
You're going to be out on course. You're going to be out on course on that long high G corner. You'll be like, I wonder how the oil pressure is, in this corner.
Yeah, that's always for me as the one who works on the car the most. That's always my biggest problem when I'm in the car, is getting out of the engineering and troubleshooting mindset and just into the driver mindset. Like, I can do it in other people's cars really easy because I don't have to build it. But yeah, that's my mountain to climb every time I get in the car.
Oh yeah, like when I'm in the car, I'm like, oh, does the app have a bug? Because the Gil is running the race capture app as the dashboard. So I'm like, is it behaving correctly? I'm like not paying attention to driving. It's like, oh shit, I need to damn it, I need to make a note of fixing that bug because that's super annoying. So yeah.
Why are we getting that weird pixelation in the corner? Oh shit, there's a wall.
Yeah. So the all along, anything real time with endurance racing, when real time data plus endurance racing, that's just definitely a win, because the car's running for so long, you need to have that insight. But definitely applies to a lot of different kind of racing. Just having that, and the more immediate the data, the better. But there is some unique features that we're adding specifically for endurance racing that just doesn't apply to other types of racing. So one of the things that we're doing is the ability to add the ability to let the system identify which driver is in the car. And the way we're doing that with the new Podium Connect Micro is that we'll put a Bluetooth tag on the driver that uniquely identifies the driver. So each driver has a unique Bluetooth device, and then when they're in the car, the system will go, oh, that Bluetooth tag is in the car, and it's the one that's closest to me, right? And then I'm going to say that person is currently driving, and then all the laps that are being logged and also live streamed will be associated with that driver ID.
Mm-hmm.
So,
smart.
So then you'll know like who's putting down what laps, and it'll just be easy to kind of compare like who's in the car at a given time, and then you'll just like all the obvious benefits from that. But the other thing too that we kind
of from a BMW perspective is who over revved the engine and money shifted it, and they won't be all, hey, it wasn't me. It was the guy before me. Well, Bluetooth
money
says
shifted
different.
it.
Yeah, Brent.
Right.
So would like an Apple Watch or something like that count as a Bluetooth device on person, or does it need to be a separate tag or what?
It could work. We haven't tried an Apple Watch, but it'll be basically any kind of Bluetooth device that's not currently connected. So like when it's not connected to something, then it's kind of like pinging. It's like, hey, I'm here, I'm here, every once in a while. So we could definitely test an Apple Watch. But what we have found is like a generic, like a luggage tag, or like a like one of those a tile, like a generic tag could work. And then what we found is a heart rate monitor, like a generic heart rate monitor, can also work. And then because those have a unique ID, so if each driver is like wearing one of these, then it'd be able to identify the driver. But then there's also the bonus ability of reading heart rate from the heart rate monitor and adding that as a data channel. So you can kind of see how.
So you start getting the biometric data in the data stream too.
So we can do that now, because I feel like we talked about that a little bit, but we can do that now. Do you think that's going to work?
Well, with the new tech that we're putting in the new Podium Connect Micro has a Bluetooth Low Energy interface, whereas the older race captures didn't have that. So that gives us the ability to talk to a heart rate monitor.
Very cool.
Do that with the previous race capture systems would require a separate device on CAN bus and be a lot more DIY, but it would be with effort, it would be technically possible. But I really like the idea of having that heart rate. Like I always think about like that one time I was at a race in Sonoma. It was a Lemons race where I was in the Peugeot, and it took me like a third of the stint to calm down, and I was just wondering like what my heart rate was at that time. But yeah, having that info would be pretty cool.
Yeah. That's awesome. So the driver tracking is really cool. I think that's perfect. And then I'm really interested. So you've got some really cool calculations now for target laps and fuel strategies and things like that. I'd love to hear more about that.
Yeah. So
especially how we can retrofit it to a race capture 3 or 4. So what we haven't talked about yet, Brent, is we were early adopters of your products, right? Like we had a race capture. The first race capture pro.
Yep. Can we back up real quick? Before that, Maury, I showed up to the team, and Maury's got some sort of logging machine. I forget what it was. It was an early logging machine, and
that's true.
And it had a like a serial out. Okay.
Yeah.
And we had this idea. We were like, what if I can get a Wi-Fi connection to that serial out and like read this thing wirelessly? So I went and bought like a wireless bridge, like a wireless serial bridge, which was just trash. And and then we were all working like, how can we extend this Wi-Fi signal outside of just like the garage? And it was a total mess. But so we had similar dreams. I mean, clearly you executed way better than we did. But so when your product came out, we were like, oh heck yeah, like this is what we need, right? So we've been here the whole time.
We saw the promise of telemetry on that thing as soon as you put it out. We're like, that's where this is going.
Yeah, it's wow, I just like all the memories just zooming back to like what that was like, and how much we've learned since then. And like they say, like the first followers are the crazy people who like trust the initial product. And it was I'm just like blown away like how hard it was to use that product at first, because it's basically like you had to have a lot of technical knowledge. Like you had to program in the start finish line GPS coordinates in order for it to work. And then you had to change that at every track. Like it was.
And then you had like a 12 character limit for Lua. Like if you could program a script in 12 characters or less in Lua, you were all set to go on that first one, right?
It was. I was surprised that it did have Lua scripting right from the beginning, but we've learned so much then, and we're still learning more. But the whole so the feature we're adding for it's really for endurance racing is there's a couple of features that are tied together. One of them is the ability to set a target lap time. And in endurance racing, that's really important because the fastest lap isn't necessarily the best lap. A lot of early endurance racing teams is they just kind of the team is kind of like just doing a bunch of sprint races kind of chained together between fueling stops, and everybody's kind of casually comparing their who's getting the fastest lap time. But its fastest lap time isn't necessarily the best. So we'll have the ability to have the pit crew send a target lap time to the car in what we call like reverse telemetry. It's like pushing the data backwards to the car, and then that target lap time shows up to the driver in a delta between predicted time and the target time. So the target, let's say the team says, "I want you to do a 2:05," right? And then while they're racing, there's a predictive time being calculated, and then the driver will see like a plus minus delta between their current predicted time and the delta, and that'll allow the driver to like maintain a particular pace. And then the reason why you might want to target a particular pace might be, let's say the race series might mandate a do not go faster than this time kind of pace, like Lucky Dog does with their Super Dog time. That might be one of them if you're running an A-class car. You don't want to like step over that line and then get penalized. The other reason is if you want to do some fuel strategy. So as you know, the relationship between your lap time and fuel consumption isn't linear. So let's say you're running at a particular pace, you're consuming, at pace X, you're consuming Y fuel. But then if you really start driving harder, your fuel consumption goes up, may spike, right? It may go up non-linearly. So there is a sweet spot between lap time and fuel consumption. It's kind of like a Goldilocks zone where you get a relatively fast lap time for a reasonable fuel consumption. And then that can inform the team what pace they might be able to run to maximize their overall stint time. We had an early lesson, like at a race with the Mercure. We had our first driver out. They set a pace. They were able to get like squeeze an hour 45 out of the tank, and we're like, cool, that's awesome. It was like one of our earlier races in that car. And then we put the next driver in, and everything was fine. They're running really like similar lap times, maybe within a couple of seconds. And then, you have that like mid-stint relaxation where like, yeah, the car's out for a while, everything's fine. And then we get the radio call like, yeah, I need to come in for fuel like soon. And then we're like, holy crap, what's going on? Because we weren't ready. We didn't get fuel. We were completely unprepared for them to come in to fuel. And we're like, we thought something was wrong with the car. And then, we later on, we realized that they were driving completely differently. Our first driver was like really smooth, really modulated throttle and brakes, smaller steering inputs. We had sensors, for steering angle, throttle, and brake pressure. So we could see all that information. And then the other driver, which was putting down the same pace, but they were doing it with a lot more effort, like big throttle inputs, grenading the brakes, big steering inputs. And then through that kind of racing, they were really burning through the fuel, and it kind of surprised us. So that always stuck with me as we're developing our product. So how that translates into the fuel strategy is that as you're putting down laps, we're collecting all that information about like what your pace is versus your fuel consumption. And then there's kind of like that sweet spot where you get a good lap with low fuel consumption, relatively low fuel consumption. And then we can recommend that lap time, and then you can send that lap time to the car for that driver to follow that pace. And then what that does is informs the rest of this strategy tool. I'm doing a lot of hand waving, but the strategy tool will plot out your upcoming pit stops based on that fuel consumption. So you could see like how many pit stops you have until the end of the race, with the ultimate goal of preventing a pit stop right before the end of the race, which could cost you the podium, right? Like if you have a last minute pit stop, that's like 5 minutes, which turns into like 2 or 3 laps. And you know how hard it is to gain laps on a competitor. And if they're doing better fuel management, they're just going to kind of like pedal past you, right? And you'll be like, crap. So this tool will literally like in a show you your fuel consumption from like now, like in any moment during the race till the end of the race, and it'll show you like how many more pit stops you have left, and it'll let you plan out your remaining pit stops so that you can optimize how many pit stops you have based on fuel consumption, and then to prevent that catastrophic, like last second pit stop, which nobody wants.
Brent, this really begs for visuals. We're an audio only podcast. Can people see this anywhere, like on one of your I don't know, webinars or anything yet? Or I guess that'll be coming out eventually.
We're doing some webinars where we're like we're showing this to people like in a like a spreadsheet, like a PowerPoint style presentation, which has been really cool because I'm getting to meet racers and find out what's important for them, and also getting some really good feedback on our fuel strategy. Like what do you do when there's a yellow flag, right? So like one of the things that we'll be able to do and as we iterate on this feature is that if you're within X amount of time of the end of your stint and you have a yellow flag, it might go like, hey, yeah, you should pit now because you're within this window of you might as well pit because you're close to the end of your stint based on fuel or time. So that was some great feedback we got from that conversation with people. So we don't have that in our marketing info yet. We will though soon. So as we just get all that info out on our website. But yeah, that's like those kind of features are super unique to endurance racing. Like that kind of stuff just doesn't exist for any other kind of racing, like time attack, sprint racing. You just want to go fast, more or less, and be consistent. But with endurance racing, it's really a team sport where you really have like a strategy for like how you want to drive, how you plan your fuel and pit stops, and going all out, going 11/10 is not necessarily the best strategy.
That's awesome. What's the kit or the future kit maybe to make that work, right? Like I don't feel like I can do that on my Race Capture 4 right now with, I need some sensors at least, but just, high level, what does that look like?
Good question. Yeah, I'm glad you brought that up because so the key information we need is like real-time fuel consumption. And that feeds into the strategy tool so that at the beginning of the stint, the fuel total is like 0 and then climbs over time as you're consuming fuel. So we need real-time fuel consumption from some source, and then that gets fed into Podium Connect or Race Capture, and then that can compute a running total of fuel consumption that's very accurate compared to like your fuel level gauge. And there are a few
what you're
ways
looking at there
getting...
is like a couple of I'm sorry, I interrupted. I think you're about to say.
Oh yeah, there's a few ways of figuring out that real-time fuel consumption. The easy button is if you have an ECU that literally outputs that information in like liters per minute or gallons per minute. Those only tend to show up in like high-end ECUs, like ECU Master has that. Other ECUs have that. You're not going to get that in an OEM application. So the other way to do it is is to there's like 5 data points, and if I can remember, you need the injector pulse width, you need the size of the fuel injector, you need the number of cylinders, you need fuel pressure, and then RPM. And then with all those data points, then you can calculate real-time fuel consumption. So that's one way of doing it. And then the absolute backup way of doing it, which is a guaranteed way of it working, is to get a literal fuel flow sensor, which installs in line with the fuel line. And then if you have a dead-ended system, then you can get away with one of those sensors. And then if you have a return style system, you need 2, and then you subtract 1 from the other. And there's one company that makes these fuel flow sensors. It's in Electronics International FT-60. I think I'm getting that right. It's for aircraft application, and that will do the trick. I think the FT-60 is good up to 350 horsepower, and it has like these MPT fittings, which you can like put AN fittings or whatever you need, hose barbs. And then that outputs, it basically has like a little fan inside of it that spins based on the fuel flowing past it. And then it outputs pulses, and the faster the pulses, the faster you're consuming fuel. And then ideally we'd want to turn that into like a CAN bus message that could be consumed by the system. Yeah. And then that just shows up as, liters per minute or gallons per minute. So yeah, those are the 3 ways of getting it.
Are those just outputting a voltage signal?
It's literally like a pulse. So it's not a variable voltage, but it's like a if you imagine like an EKG or something, like in a hospital or an oscilloscope, there's like a little blip every time the fan rotates, and then the faster those blips are, the faster the fuel is being consumed. And then there are ways of turning that into a real world number.
So that was my follow-up question. I said, how do you get that into the CAN bus?
Yeah, so that outputs a square wave signal, and then you can read that in by using a microcontroller, and then you would basically count or basically time the time between pulses can be turned into a real world number through a formula, and then you broadcast that out on CAN bus.
Easy peasy.
It's super easy.
So where do you get the microcontroller? Is that a DIY thing at this point?
It could be. You could do a few different ways. You can get an Arduino and a CAN bus shield, and like read that sensor and like write some Arduino code and then output that on CAN bus. We have a little a development board that has CAN bus built in that could be used. We're going to also build a dedicated sensor device that can output that on CAN bus if people want that. But we haven't built that yet, but it is something that is coming. But that should be a fairly straightforward device compared to some of the other stuff we built. But yeah, that'll be
the PayPal invoice. Give me the PayPal invoice now.
Yeah, it'll be easier than like our tire temperature sensor for sure. But I think that'll be a useful thing for people to have, and it'll be universal, which could be used with any data system.
That real mathy way with the pulse width and everything. So, what do you need there? Just a fuel pressure, like from a physical sensor standpoint, or I mean,
if you're doing it the other way, yeah. If you're measuring the pulse width from the injector, then you need a fuel pressure sensor on the fuel rail, and then that gives you all the information. If you have RPM and the other data points, yeah, that's a little more sane way of doing it, I would say. Okay. And then, yeah.
I mean, I'm right there, so I think I have all that kit ready to go.
Oh, cool.
All right. Well, this is very exciting, and I'm sorry it's an audio only podcast, but I'm sure our dozen of listeners will be furious. What, Brent? What else?
Is that calculation all just on the? It's all just on the software side of things. So it's you're just putting that. You put that data into the air, pick it up in the telemetry. You're running the race capture software on your laptop in the pit, and that's showing you it there. And then you're either pushing it back to the car via a display or just informing your driver over the air.
Yeah, I would say like our philosophy is to have the device in the car compute as much real world information as possible, like at the edge, so that whatever gets sent as telemetry is useful information. So one way that could be done today is to write a Lua script that would take, injector pulse width and RPM and fuel pressure and all that stuff, and then just do that math and then set it to a virtual channel that would be called fuel consumption, right? And then that would work today with the current race capture systems. And then yeah, we're really big on making sure that our existing tech can work as much as possible, as long as possible, without we don't like the whole iPhone style planned obsolescence.
The enshittification.
I might be picking on Apple, but like other companies do that, right?
Right.
So yeah, so maybe at our own bad business practice, at our own detriment, but we've worked hard to keep as many of our products up to date on firmware and features as we can. But like when we release new hardware, if there's a capability that the original system can't possibly do, like the Bluetooth Low Energy to like a heart rate sensor, then that's a new capability that's just physically impossible. And then like the Podium Connect, the new Podium Connect Micro has more RAM and flash, especially with the RAM. So like Lua scripting has much more space available for people to write their scripts that run on the device, which is something people have been asking for a long time. So that's another thing that it can do.
Nice.
Yeah.
Great stuff,
so
man.
Let me ask you a question then. So if you've got that kind of target lap that you want to be pushing to your driver, then how do you get that to them? Does that have to be on a? I mean, obviously you could radio it to them, right? But if you want to do it visually, does it have to be on like an RPI display, or can you push that? Will it be on the CAN bus, and then it could come right into like an AIM display?
Yeah, this is kind of how it works. So in the Podium app that's running on your screen in the pits, your laptop or whatever, so you would put in that lap time and you would hit send, and then across that telemetry link, it gets sent backwards to the car, and then the race capturer or the Podium Connect device receives that message and then sets an internal channel called target lap, and then you'll know that it was set because the target lap channel gets updated with the value you just got, that you just set it to, and that target lap just becomes another telemetry channel alongside engine temp, RPM, or whatever. And then internally, it'll do the calculation between the current predictive time and the target time you just set. And then there's like a target delta channel that also gets created, which will be like, plus or minus seconds. And then all that shows up in your live telemetry that gets broadcasted up to Podium. So you kind of see the history of that. And then that info can be shown on the Race Capture app that's running on an Android device, as you can use that as your main dashboard or an auxiliary dashboard. If you have like an AIM system or some other data system, you can kind of have that off to the side if you want.
I got you.
Or we can broadcast that over CAN bus, and then your data system can ingest that as another like a data point that could show up in the AIM or ECU master or Motec system or whatever you have, and then that could be shown to the driver as a like a channel of data on the dashboard. So it'll be pretty flexible as to how you want to do it. A lot of people are running the Race Capture app on a mobile device or on a Raspberry Pi, and it could show up that way, or it could be broadcasted over CAN bus to other systems that can handle it.
Slick.
Yeah.
I have a quick plug for an idea. So you talked about endurance racing, but for sprint racing, right? I feel like the resource you're managing is tires over, let's say, a 16 lap sprint race. They can, become overheated, or, they might be better at the beginning or the end, that type of thing, right? So it'd be interesting to, like, especially if you could do some learning, right, to say, with your tire temp data, right, and possibly your average lap time for the event, something to that effect, right, and how that changes over time, and try to get a target that way too for the sprint racing. But that's clearly not your target market right now, but just think of other ideas to kind of use that feature.
Yeah, that makes me think of like overall tire conservation, and yeah, it kind of does matter in sprint racing, especially with the tire temps can inform you if you have alignment issues or other problems, so you can maximize your grip. And then that affects lap time as well. So yeah, that's definitely useful information.
Yeah.
I wonder how I don't know any of this, right? Just thinking, and of course I don't do any sprint racing. You do some, Murphy. Like part of the thing that's interesting with the endurance racing and what Brent's talking about, like, you think about tires or fuel, is that there's also a time function, right? Like you're averaging this over time a little bit, because we all know from doing endurance racing, things can change drastically from lap to lap, or one lap and then 3 laps, because you get behind, in Lemons racing, right? You get behind a Chrysler minivan and get behind, like a Dodge Dart, and there's a cluster of slow cars for a lap that cause everything to clog up or whatever, and then which could throw your calculation all off in a 10 lap race, like in a sprint race, right? But it's a little bit less of an effect when you've got when you're going to do 300 laps in a day, right? It kind of works. It kind of just works out in the averaging. And I'm wondering if, like with your tire data, Matt, like on a lap by lap basis, I wonder how much variation you see in tire temp versus lap time, right? Like, because I get where you're going. Like, if those tires get way too hot, they're not going to be as grippy. You're going to want to see it, like maybe dial it back a little bit. But I don't know how you report that into the driver from a data perspective. Like,
well, you can still send that target lap, to the dashboard, I guess, right? But I think you would need to learn like lap over lap or race over race too, to see like if there's a massive fall off at the end, like depending on your behavior. So it would take a lot more data to kind of learn what the best, and maybe that's something you have to do in the data, and then set some target lap times at a later date, right? It might not be all
that'll
that
be
live.
that'll be in Race Capture E5 AI.
E5 AI. There you go.
I like it. The other data points that are really useful, like when you're talking about tire performance, and a lot of that is affected by ambient temperature at the track. So that if that could be logged over time, so like ambient temperature, humidity, whether it's wet or not, that could be really useful information. And then so you could be like, okay, so the average temperature for that day was 54 degrees or 70 degrees. But if that's actually logged over time, during the race, because weather varies during a long race. Like maybe it was warm, and then the weather turned to crap later on. So the more information you can correlate with the data while it's coming from the car, the better.
Yeah, we're in our part of the country, like where you see, like your first session of the day might be much cooler than your 3 p.m. I mean, you can see a 30-degree ambient temperature swing, like without any question.
Hear me out. Okay.
Why are the tires greasy? Well, it's because it's so much hotter.
They started off at 95.
In-car temp sensor, driver heart rate, water flow to the cool suit, right, and temp. There you go.
Yeah,
that's right. Yeah, there's another. That's a correlated data point too, right? Like, what's our flow rate? What's our temperature and flow rate on the cool shirt system?
Yeah, that's been a problem.
The thing is, it's like you want all the data, but you don't want to be drowned in it by default. You just want the high level stuff, and then if there's something weird, then you have an opportunity to start digging in to like correlate, what was going on. Yeah.
Yeah, that's awesome.
Yeah, so Murphy, maybe I'll put a CAN bus water temp sensor on the the cool shirt for Hallett. We'll just throw that into the data stream and not do anything with it during the race, but then we'll have it afterwards to be like, oh, look, well, Murphy was running great laps until, his heartbeat was 170 beats a minute, and and the water temperature was up to 95.
Right.
Wasn't cooling him at all.
Yeah, with these heart rate monitors, some of them I haven't found one yet that has SpO2, like the oxygen levels in the bloodstream, but that would be another one. You're like, are you suffocating? Are you getting carbon monoxide poisoning in the car? But yeah, that's people. We support like 100 CAN channels, and at when we kind of designed it, and it's a nice square number, right? 100.
Right.
We thought nobody will ever need that many channels, and then people are like, I need 500 channels. Like, okay.
Wow. Okay.
Yeah.
What do people need 500 channels for?
Yeah, no kidding.
Brent, what are people using the 500 channels for? Are people really going over 100?
This is for like people who are doing like, I think a few teams that do like the 24H series in Europe are asking for that kind of stuff. Like we got an inquiry from a factory team from Japan wanting a very high-end, solution for their car at 24 hours of Le Mans, 24 hours of Le Mans in France. So we had an extended conversation with them about that. So it would be nice to see our products there eventually.
That's awesome.
Yeah, you can get a paddock pass to support them and all of that.
Yeah. Yeah, if you need like an umbrella girl or something.
Yeah, it would be nice to just like be there in any capacity. We had there was an electric motorcycle team running Isle of Man TT that was running our telemetry. Unfortunately, the cellular there was very spotty, but the whole idea of that was pretty exciting.
That's awesome.
That's where you need Starlink.
Right. Yeah, like a Starlink Mini on a motorcycle. I bet somebody could jam that on there.
Mm-hmm.
On the tail. You got room on the tail of the bike. It could work right into the fairing.
Yeah.
Question.
I'm
thinking. Yeah, I had a note here as we were talking through all of this that, thinking through when we were on the Race Capture 1, and now I've got a 3 in the car. I've got a 4 sitting in a bin in the garage. I just haven't gotten around to putting in the car yet with everything else. But like, what a revolution it had to have been for you to be going from primarily analog channels coming into the machine to making the jump to doing mostly CAN bus, and then having to make accommodation for analog channels.
Yeah, it is nice to. Well, you could just put so many more sensors on the same wire, with that.
Yep.
And it was when we did our tire the Tire X tire temp sensor crowdfunding. We developed the sensors, and then it was like, oh crap, people are gonna have to wire these up, and they're gonna get, it's kind of complicated to wire up CAN bus signals. And you have to use twisted pair wiring. You have to, wire it up correctly. You have to use proper termination. And then we just kind of like, I had a moment like, oh my God, we better make this thing easy to install, or else they're gonna be frustrated, and we're gonna be slammed with, support inquiries, because people, might be having problems wiring the stuff up. And so the more important part of that crowdfunding campaign was the plug and play harness that we had with the tire temperature sensors. Because after almost everybody picked that option, and it was a big relief, because we had like close to zero inquiries around like wiring it up, and it's like, it's not working. We didn't get any of those. Like, I can't get it working. If they just plugged it all together and did it in the right order, then it springs to life, and it just works. So we kind of ran with it, and that whole plug and play concept with the wiring harness just kind of snowballed into everything for CAN bus as well as the analog and digital sensors. And like when I think about the first gen race capture system, it's just you just I wish I could just like time travel and like imbue myself with that wisdom of what would be important, and just like making it easy as much as possible, would right from the beginning would have been huge. So I think we've kind of been, I would say like a little bit dogged by the legacy of like it's a techie product that's hard to use, and I think we've been like trying to overcompensate, just to kind of really get the message out. Like we're really worked on making this thing super easy to use, with the like wiring up sensors and harnesses and stuff like that. I know you don't have to do any custom wiring with the system if you use our plug and play harness. So, I mean, really felt like we were feeling the pain. It took a while, but we're really feeling like the pain of just wanting something that's like the easy button that just works. So that's a huge part of like what drives our philosophy in terms of developing our products.
Well, I'll give you an affirmation on that, because we certainly were one of the crowdfunding teams on that. Like Tire Temp, it was sort of like the Race Capture 1 from the very start. Like we saw the promise of where this thing could go and wanted to get on board right away. And it was the same thing with the Tire Temp stuff. Like, hey, this could be really interesting data, especially if we're getting tire pressures wrong, or we've got our alignment really wrong, so that we're seeing really high temps on the inside edge of the tire versus the outside edge, or really high in the middle versus the edges or whatever. And I gotta say, when I installed that, it worked right off the bat. And I mean, how many times, especially with electronic systems, new aftermarket electronic systems on an existing car, never. I mean, how many times can you say that that's worked the first time you plugged it all together? You had to wire it all up yourself. Like, you didn't misconnect something. You didn't, blow a crimp somewhere. You didn't forget to plug something in. I mean, there's 1,000 points of failure, right? Kudos, Brent. It worked. Like it worked right off the bat.
Wow. That's really cool. I'm glad you had a good experience with that. Yeah, I remember when we were fulfilling that crowdfunding campaign, we were like, I think quite a few of the kits we were just like plugging all the sensors into all the harness, like set it up as if it was, and then like plugged it into a race capture, and did they all light up? Yeah, all the sensors light up, because we were just really determined not to have people have a bad experience.
Yep. That's all.
QA and QC's got to be a level of work that, like, from the very start, you never anticipated being necessary to go into building this product. And then it becomes like, if not the most important, one of the most important parts.
Oh yeah, like the test bed that we use for like one of our devices, we put like twice the amount of work in the test harness to be able to quickly make a thing, and test it, write the firmware, and then it goes through the battery of tests to make sure it works correctly. Yeah, it's kind of nuts. Like it's one thing to do a one-off, but to like plan to do thousands of something. Like I think I'm kind of damaged in a way, because like I can't do any fun custom projects anymore. I always think like, how do I make 1,000 of these? That's where literally where my brain goes. Like I can't just do a bespoke project, right? It would be like fingernails on a chalkboard. Even if it's something I don't need to mass produce, my brain goes like, how do I mass produce this thing? Because it doesn't even need to happen. So
I think that's a natural part of the design process when you get to like any real stage of maturity, right? Like where it's not going to possibly be the only time you ever see this thing. I'm thinking about like my own experience in using Fusion 360 and iterating parts on the 3D printer, whether then it's going to go into use like that in a non-structural, or if it's something that gets sent off to be not even CNC, but just something flat to send, cut, send. And from the very it used to be, it was like one part and you wouldn't think about it, and now as you do it more and it gets more complicated, you're thinking about from the start of the design, because you've had this experience at the end, like, oh, I want to go back and change that. Well, how do I do that? Oh crap, I've got to go undo 16 iteration, like little iterations to get, this width correct. Whereas if I just done parametrically at the very start, and constrain this properly, I could just go in, change that one variable at the very start, and the computer would figure out all the problems, right?
Yeah. Yeah, it makes me think like decisions have very long tails. Like our first gen race capture system, we had an off-the-shelf enclosure with these blank end plates, and then we had like a Harbor Freight CNC mill that we converted to a Harbor Freight benchtop mill we converted to CNC. And then our production process was to put like an end plate in, hit the button, let it in, and it milled out the hole in the end plate, and then you take it out, put the next one in, and then it would have coolant spraying on it, and our hands would be soaked, and we'd be sitting there for hours just like milling out end plates. And that really, after that experience, all I could think about was like, how can I make it easier to manufacture, because this is kicking our ass, like doing all this custom work every time. And then we'd make like the next version and be like, wow, this is so much easier, and then that becomes annoying. And then the next version after that, I find like some aspect of it is super annoying that ends up grating on me. So the next version, I'm just trying to make it easier, simpler, more reliable. So that whole design, the concept of design for manufacturability is huge, and it's something that's kind of like people aren't really aware of. Like the person that may buy a product, they don't see the kind of like that, what goes on behind the scenes to try to get something to be better overall, especially in manufacturing efficiency.
Yeah, I think we try to build our race cars for serviceability, right? Like how is this not going to be a nightmare at the track, right? But I can't imagine.
Oh yeah.
How do you build 1,000 of these? Yeah, that's beyond my skill set for sure. Guys, we probably need to wrap this up. We're getting a little long in the tooth for a podcast, but this has been a real fascinating conversation. Pat, I feel like you could just keep asking questions for days, but do you have any other final thoughts? I mean, I think
I do. I was talking to a friend that we were going to be doing this podcast. And he asked me, he's in the stage of doing some stuff, and he was thinking about, he's got an AIM display, and he's got a Race Capture Pro, sucking in basically pretty much all the data. And he just wants to connect them together. Is that just plug them both into a data hub off of the AIM and let the CAN bus figure it out?
Yeah, the Race Capture Pro has a CAN bus connection, and then that can get plugged into the AIM hub. And then AIM has a really convenient, pretty standard data stream that gets broadcasted out to their SmartyCam, which we can just listen to. So when they configure that data stream for the SmartyCam, like I want like RPM and engine temperature and a few other data points, then that can be broadcasted over that SmartyCam connection. And then those channels can get mapped into the race capture, which we have a CAN bus preset for. And then that'll get blended with the rest of the race capture data and then broadcasted via telemetry. So there's definitely a way of doing it.
Yeah, it doesn't even sound very complicated. You didn't have to say, you didn't say Lua at any point in the entire process.
No. Yeah. Lua is like the escape hatch of like hackers wanting to customize the system, but it's not required. Yeah.
Nice. Yeah, it seems pretty straightforward. And do you have a mapping already, like a CAN bus mapping for those AIM systems?
Yeah, there's two different ones. The one for Podium Connect has the GPS information along with all the sensor information. That's what we use for AIM. And then there's one that has just all the sensors, because Race Capture has its own GPS. So that you go into our presets, select the sensor only AIM mapping, and then set the baud rate, and then kind of should spring to life, and you could see the data.
Nice. That's slick.
Cool.
Brent, anything else to close us out? Do you have any shout outs? Maybe promote the website and next event, something like that. I don't know.
Oh wow, yeah. So I think, yeah, we so I would say our marketing is kind of crappy because we're a very engineering focused company. So we're working on being better about that. But yeah, go to autosportlabs.com. We have a mailing list. You can sign up. We're going to be doing a promotional pre-order for the Podium Connect Micro, and then we will continue doing that for future next gen products. And we're doing one more webinar this week, which might be already done by the time this drops. But we love talking to racers and learning about what's important for them. I think that's really what I've been getting out of these webinars. It's kind of like a ransom for, like, I'm not going to tell you what we're working on, but I want to talk to you. Right. Whereas before it was kind of been transformative for me, because before it was like, I'll just send out the information on our webpage. Don't talk to me, just buy our stuff. So I really do. I'm really, really enjoying talking to our customers much more nowadays. So yeah, you could drop us an email, find me on Facebook, or just through our website contact. And happy to hear about your racing and what's important for you, and can kind of go from there.
Awesome. Yeah, and I can vouch for that. I mean, Brent's always been really, responsive. I think people get bunged up, like they can't just reach out to the guy that's selling the product, right? Like they got to find it online or put something in a, some forum, right? But no, just call Brent. Like, the guy's super helpful. So, yeah. Very good. Pat, any shout outs?
No, Brent, like you've heard, we're longtime customers here at TARP Racing, and have really appreciated the products, and even through the ups and downs and the learning curves, the promise is so strong. And I'm really excited. Like I said before, I'm really excited about the fuel flow calculation data, being able to optimize that, because that's, well, I only endurance race. Matt does some sprint stuff too, but like, I see that as such a valuable. It's funny, Murphy and I were talking about before we got on the pod that I was looking at this exact problem, and the other and I made a motion. You didn't see it because you were looking away, but at Murphy, the fuel flow sensors you were talking about were the exact ones that I was looking at. Some other guys that have kind of done some other calculation stuff on it, and I'm like, well, these are all kind of kludgy. I see where they're going, and the electronics part is not my forte at all. Like, other than I like using it, I see the value of it, but I'm not a programmer. I can't do any of that. There are other guys on our team that can. It's not me. I'm really good with a pair of like snips, and I can crimp the hell out of anything at this point, but I can't program. So I'm super excited for the fuel flow stuff to come through. You put a crowd fund out on that right now, and I will be the first one on your Indigo or whatever it is.
There you go.
Cool. I love that. It's kind of what makes me get up at 4:30 in the morning, because insomnia. But yeah, it's I mean, yeah, it's like I wake up and my mind starts racing, and I'm like, all the things I want to do. But yeah, that's exciting to hear. So thank you.
Yeah.
When's Brent? When's the next race for you?
Potentially April at the Ridge. I reflexively said Sonoma. I love Sonoma, but yeah, it'll be the Ridge with Lucky Dog.
Nice.
So that is the potential next race. But I would love to guest drive anytime if anybody needs an extra driver. So
good place to put it out there. Did you see the Lemons announcement this weekend that they're doing Thunderhill in May? No, is it in May? Whenever Thunderhill is, it's coming up later this late this spring or early this summer. Might be in June. Is going to be the 25 hours and 1 minute of Thunderhill. It's going to be the first time that Lemons has done an overnight race on the West Coast in like 10 years.
Okay.
That'll be epic. Wow.
So pull the Mercure out of the mothballs.
Yep. Well, very cool. Well, you can find us coming up here these next couple of months. I'll be down in Houston, April 12th, 13th for the NASA Texas event, and first time running ST4 and first time back in NASA in a couple of years. And then Mulry's going to be leading up the team there at Hallett May 3rd or so. And so we'll be all up at Hallett in the Miku BMW, the red Miku.
Hopefully more than just Friday morning testing this time.
Yeah, we're going to do more than win practice this time.
That's right.
We got this.
That's the goal.
Yeah, so we actually mean it now when we say we'll see you at the track. But yeah, check us out on racershq.com. Check us out on YouTube for some reason. Listening to us just play our logo for 2 hours is something people do, but whatever. So yeah, check us out on the grams, whatever you need to do, and we will see you at the track. Bye, everybody.
Good night, Dave.
Bye.